Hey, good morning. Welcome to
KidMath97.
KidMath97. So today we were going to do kind of a fun little talk about functions, just to show you that there is a little bit of subtlety to functions. So we have this one function, x squared minus 1 over x minus 1. And we have this other function, which is x plus 1. So first, find f of 2 and g of 2.
Well, f of 2 would mean 4 minus 1 over 2 minus 1, which is 3 over 1, so just 3.
Okay, good job.
Then g of 2 is 2 plus 1, which is 3.
Okay, great. How about f of 5 and g of 5?
Alright. F of 5 and g of 5, we get 24, 25 minus 1, over 4, which is 6. And then 5 plus 1 is 6. They seem to come up with the same answer.
Ah, okay, great. That's the next question. Are these functions the same?
Well, the functions themselves, x plus 1, well, I'm not sure if these are the same, but the answers always come out the same, it seems.
It does seem like that. Why do you think that would be true? F of x is x squared minus 1 divided by x minus 1, and g of x is x plus 1.
Well, maybe we could try to turn this equation into this equation.
Okay, how would you do that?
I factor out an x minus 1 at the top.
Okay.
So your x minus 1 times x on the top over x minus 1 times 1.
Alright, would you multiply this out for me?
X minus 1 times x. Oops. We have x squared minus x. That doesn't seem to work.
Okay.
So, well, x minus 1 squared. Squared is this is x squared. Actually, we could do a difference of squares here.
Ah, interesting.
So this can factor into x minus 1 times x plus 1, and then when you multiply it out, when you multiply, you have minus x and then plus x, and then you have minus 1.
Okay, so x squared minus 1 factors into x minus 1 times x plus 1. Good job.
So these two cancel, and we're left with x plus 1 over 1, which is just x plus 1.
Aha, okay, so there's an explanation of why we've gotten a lot of the same answers, but it still leaves an open question: are these the same? Okay, and the answer is that they're not. Okay, do you have any guess as to why this function and that function are not the same?
Well, we have minuses here and we have a plus here.
Well, those do factor out. There's a really important reason why this function is not the same as that function.
This function has an x squared term in it, but
That's true.
that also factors out.
Okay. What is f of 1?
F of 1 is 0.
How did you figure that out?
1 squared minus 1 is 1 minus 1, which is 0.
Okay.
And 1 minus 1 is also 0.
Alright, so what is f of 1?
0 over 0. But you can't divide by 0.
Okay.
So it's undefined.
X equals 1 produces a 0 in the denominator.
Which we don't like.
Okay. Which you can't have. X equals 1 is not defined. So what I want to say, x equals 1 implies f of x is not defined. I think that's not exactly the right way to say this, but what I really mean is f of x is not defined at x equals 1, right?
Mm-hmm.
You can everywhere else, this function
This
looks like x plus 1, except very importantly, it is not defined at x equals 1. So
and
if you were
g
going
of x is.
and g of x is. If you were going to graph this function, g of x looks like this line y equals x plus 1. f of x looks exactly like this line, but at x equals 1, we have to remove a point.
So it's like a line with a hole in the middle.
It is a line with the hole in the middle. Okay, so that is the subtle point I wanted to talk about domains and ranges. So you have to make sure, if you're going to say two functions are the same, you have to make absolutely sure that they are defined everywhere. And
Yeah.
this one has a hole in it.
Yep.
Okay. Good job, man. Talk a little bit more about that later today.